You've seen how preferences allow us to send data up from a child view to its ancestors, and it's down to us to decide what to do with that data, if anything at all. Well, SwiftUI provides a handful of specialized preference modifiers designed specifically to make it easy to share sizing data and use it. To show us off, we're going to make a simplified version of the Airbnb toolbar. There's a whole bunch at the top of categories in their Explore tab for things like beach holidays or golf holidays, if you want to. And you can swipe through them all and tap on one to make it underlined and selected. And the underlined moves around between categories and resizes correctly to match the length of the text. We can recreate that with SwiftUI's preferences. And solving this will show you not only how more advanced preferences work, but also how the preference data can be more complex. That what we actually share isn't a simple value, but actually complicated things if you need it. Definitely a fun problem to tackle. Anyway, first things first, we're going to define what one category in our app looks like. And we'll have two properties here. One for the identifier, which would be things like, is it a beach holiday or a golf holiday or a tropical holiday or whatever, plus one for the SF symbol to represent that as an icon. We'll make this thing conform to identifiable, so we can make loops of them in SwiftUI, and also equatable, so we can compare one category with another. So we'll say a struct called category, which is identifiable and equatable. It has an ID string and a symbol string, like that. Next will be the preference data we want to share. Now previously there was a simple number here, but I'm going to share a custom struct containing two pieces of information. One will be the category that it refers to, and the other one will be an anchor, which is SwiftUI's type that stores an opaque piece of geometry. What that means is it can store a reference to some kind of position or size on the screen, but we can't read it out from there directly because it just wouldn't be useful. Does it refer to the absolute coordinates or relative to the child or the parent or who knows what, right? Fortunately, SwiftUI knows how to read anchors for us and will automatically resolve them according to our current coordinate space in the way it's useful to us. That sounds fuzzy, relax, it'll make sense in a moment once we start using it. For now, add this second struct to store the category and its anchor. So struct category preference is equatable, the category is a category, and the anchor will be an anchor of CGRect, storing its exact bounds on the screen. Next, we're going to make another struct, a third struct, that conforms to the preference key protocol. This is similar to the preference key we had before the sizing view, except now we're going to send back an array of all the data at once. We'll collect whatever array we had so far and append new values to that, making one super array of all our values at once. So we can say there's a new struct called category preference key, which is a preference key. The default value will be an array of category preference keys, like that, preferences, empty by default. And the reduce function will take the current array and a new array and append it, making one big array. So we'll do value.append contents of next value. So we'll end up with one big array of all our category preferences for all our categories. And this lot here completes all the data we need for this work. So now we need two SwiftUI views to render it all. One to handle a single category button on the screen, and then one to handle an array of them drawn with the underline as well. First, the category button. This will be given the category to show, plus a little binding to store which is currently selected. That binding matters as it allows our button to say, I've been selected, adjust your external state. So we'll say struct category button is a view, has those two properties, a category and a binding. The binding will be a selection, which is an optional category, nil by default. And then in its body here, body, we'll have a button. And when it's pressed with animation, we will say, I want to update selection to be our current category. And the label is going to be a VStack showing an image, system name of our category symbol, and a text of our category ID. The way Airbnb does it is with a plain button style. And to make VoiceOver work well, we will add this as an accessibility element, grouped into one thing, with a label, access label, there we go, of category.id. So I'll just read beach rather than having two different views here. Now, we'll come back to this in a moment, add more stuff to it. But first, I want to create an initial version of our content view, which has the job of showing several of these buttons in a single H-stack. We're going to add more to that shortly as well. So I'll also create a V-stack inside here. We can add things later on. But the important part for now is it'll have an array of categories to work through, plus a single piece of state to track which one is selected currently. That's what gets passed into the category button as a binding. So I'll say first, our selection is private var, selected category is an optional category, nil by default. And the categories array will be 3 examples from Airbnb. So category with ID Arctic, symbol snowflake, oops, comma. Then category ID is beach, and symbol will be beach.umbrella. Umbrella, there we go. And then category with the ID of shared homes, symbol will be house, like that. And now in our body, we're going to add that V-stack with only one thing in for now, which is a H-stack, spacing of 20. We'll loop over all our categories here with one category coming in, category in, and place that into a category button with the category of our category and a selection of $ selected category. So it changed the external state when the button's pressed. And at this point, you can run it if you want to. It's not very impressive. You'll see the 3 options here all being well. Have a little think. Come on, you can do it. Come on. Nothing at all. Cool. Let me give it another try perhaps. Run it again. Oh, no, you can't even kill it. Cool. That's lost the plot. Good to know it's got on my side today. Ah, yes, you've crashed, have you? There you go. Preview crashed. Cool. It's all going totally to plan this time. Crashed again. Ah, I can see why. Sorry. Mistake in my code. There should be a dot there. That's the reason my code's gone completely berserk. I forgot a single dot. Thanks, 50Y. Let's try again. There we go. Again, when it works with the extra dot, it is not impressive. We see our 3 little icons here. But we haven't linked them together, right? There's no way of showing what's selected right now or similar. And to do this means introducing 2 new modifiers, one to send the value upwards as a preference, and one to read through the array of values sent back once it's been through our reducer function. Now, previously we used the preference modifier, sending a preference upwards to ancestors. Here, we'll use a specialized preference modifier just for geometry called an anchor preference, and it takes 3 parameters. One is the key you want to set. For us, that will be our new category preference key, just like we have with a simple preference. Second, you will say what part of the geometry you want to send. Perhaps you want to know just the leading edge, for example. Here we'll say, send the whole bounds. Give me the whole bounds of this thing and send it upwards. And third is a function to transform an anchor that we receive. Here's your anchor, here you go, with our bounds inside. Convert that into whatever input you need inside your preference key, which for us is going to be this array of category preference here. So we're given the anchor for one view. We'll make that into a category preference with the category it's attached to, make an array out of it, and send the single element array upwards. So down here under our label, I'm going to say there is an anchor preference for the key category preference key.self, value of bounds, and the transformation function. This is going to be make a new category preference with the category being our category, anchor being $0, whatever's passed into the function. It's anchor, like that. And I've missed a parenthesis. There we go. Boom. So now we're telling SwiftUI we want to express an anchor preference for this view for the category preference key here. And it's got to use the bounds of this whole button. And it will mean post upwards to whoever wants to see it. And we'll receive that bound as an anchor and place it inside this category preference object array. So that'll set the preference for each button, but we still got to read that somewhere else and act on it somehow. And this is where the second other modifier comes in. It's called overlay preference value. We used on preference change previously, a single value coming in. This time it's an overlay preference value. Has the job of reading a preference from the child view somehow and convert it into an overlay. So it's basically a combination of on preference change plus overlay. Make me an overlay view while this thing changes at the same time in our code. It makes our code much simpler. This is where SwiftUI performs a beautiful little trick. I said earlier that an anchor is an opaque piece of geometry. It's an opaque geometry store, and that means they contain geometry data in there somewhere, but we can't read it out because it wouldn't have any meaning. You know, it's like x35, y58. What does that mean? Unless you know what coordinate space you're measuring that in, it's useless. Swift solves this with a geometry reader. If we use one of these anywhere in our view layout, it can receive an anchor in its proxy object and have it send back that frame as a CG rect in its local coordinate space. And that means the proxy figures out automatically how to convert the original frame, wherever that was in our view hierarchy, into the coordinate space the proxy is working in. Very, very powerful thing. Takes away all the hassle of trying to figure out where the two are in relation to each other here, and just sends us back the bits we care about. A CG rect telling us the frame we actually want to use to refer to the original bounds we set in our anchor preference. Enough chat. Let's put some code in place so you can see it in action here. Go ahead and add this to the VStack. There's an overlay preference value, right? I'm going to specify the key in the transform. So the key is going to be category preference key.self, and the transform will be, well, give me the preferences coming in. That'll be the array of category preference keys here, and use a geometry reader with a proxy coming in. And we'll use this here to decide what we want to show. We've got all our preferences coming in. We can now say which of those match our selected category. We can say if let selected is preferences.first, where $0 category is equal to our selected category. If we find one of those, great. Let's go and use it as our selected frame right there. Selected category anyway. We can now say the frame will be our geometry proxy using selected.anchor. Give the proxy the anchor directly. Then draw a rectangle filled in with black. Frame will do width, frame.width, and height of 2. And then a position. X is frame mid-X. Y is frame max Y. My phone's jumped off the table again. If I type that hard, phone, you're running away from me. Frame.max Y. Like that. Okay. I'm going to break that down for you line by line, but please first run the code. Give it a try, see what you think. I can choose Arctic. There's my line matching the exact length of Arctic. Shared homes, it slides across and stretches out to shared homes or beach. They all resize correctly and move around exactly underneath the thing that is currently selected. It's a great effect. Although again, I should say, this is Airbnb doing it, not me doing it. I didn't come up with the idea, I'm just doing the code for you. Anyway, let's break down the code piece by piece. This overlay preference value modifier here, we use this thing to specify we want to read in a particular preference key, this one right here, and convert it into an overlay view for our screen, for our VStack somehow. As a reminder, that means we want SwiftUI to place some kind of view over our VStack, and we'll use a preference key to figure out what that view ought to be. Second, inside there, we use a geometry reader, so we can evaluate our geometry somehow. This will automatically fill up to expand all the available space, which is fine, because an overlay here, it means it'll naturally fit the same space as the view it overlays, which is our VStack. So it won't fill the whole screen, just the VStack space here. We then look through all the category preferences to find out which one was the one we selected. And we'll just get a whole array of them here, Arctic, beach, and shared homes, find the one that's actually selected. If we find a match, we then pass that preferences anchor into our proxy right here. So give it the opaque geometry store, we'll get back the actual frame here. This performs a conversion for us in coordinate spaces and hands us back a finished frame representing where that anchor ought to be in the coordinates of our current geometry proxy. That's what it's doing here. And now we've got a real frame, right? So we can now draw a black little rectangle that match the width of the thing we're working with and position it directly underneath as well. So we're positioning it here so its center lies at the middle bottom of our frame. If you prefer using offset rather than position, you can do that. Just use min-x rather than mid-x, otherwise it'll get confused. The real power here, the real magic of this code is a single line right here where we do proxy selected anchor. This thing takes care of all the geometry conversion for us. Hopefully you can see now why the anchor can be opaque. It's important. We don't care what the actual numbers are, we just care what the finished frame is relative to where we are right now. The real power of this approach is that the rest of our UI has no idea that preferences are being set or being used at all. It doesn't actually care, which means if we add more to the VStack, it would just work without any extra effort from us. For example, we could say under our HStack here in the VStack still, we can add a whole bunch of categories of stuff and let the user choose one that way. So we could say something like list categories here, boom, read these things in, give me one category coming in. I'll do a HStack inside there with a button saying category.id with animation, selected category, come on Hudson, selected category is that category. And then next to it, after the button, I'm going to say if selected category is our current category, then add a spacer with an image showing system name, checkmark, like that. And so now we're adjusting selected category when each row on the list is tapped, which will trigger body to be reinvoked and it'll update the overlay preference correctly each time. And you should find that as we tap our way around, it selects different rows correctly, or we can select up here. Doesn't matter. We can choose it from A or B and it'll change the whole preference key all the way through the whole system. We can also, if you want to, show the selected category by adding another view to the VStack. We're going to set something like underneath here, if let selected category text selected is selected category.id, like that. And again, that'll update. So it's Arctic or beach or shared homes down here. We get both the underline moving, the checkbox moving in the list, we get the text at the bottom updating, all thanks to SwiftUI's preferences system. Whew. So I think it takes a little understanding at first, I acknowledge that, but I hope you can appreciate the power being exposed here. These opaque anchors are really, really powerful things. We're sending complex data around now. Unique struct up to parent views. We're converting coordinate spaces and more, all to quite elegantly achieve a very specific result.